Hello, everybody. Thank you so much for joining me today. In today's little mini lesson, we are going to be learning how to go back and forth between radians and degrees. So let's go to a clean page and begin. So first of all, we kind of need to answer the question of, well, what is a radian? That's kind of important to know before we begin talking about how to convert between one and the other. So here, let's draw a circle. If we have, here I kind of want here we go. Let's draw some circle. So if we have a circle, a radian is simply the angle in which the arc length and the radius are the same. So let's draw a picture. Here, if we have some radius, r, and let's say our arc length right here is also equivalent to our radius, then that is defined as 1 radian. 1 radian, again, is whenever your arc length is equivalent to your radius for some angle theta. Or in other words, theta is going to be equal to your arc length s divided by your radius. So let's just make a example. Let's clear this out. Let's say our arc length is equal to 10 and our radius is equal to 9. Then what does theta equal? Well, theta would be equal to 10 over 9, and of course this is in radians, so theta would be 10/9 radians, or as a mixed number, that's 1 1/9 radians. Okay, now I want us to think about what we know about circles. If we have a circle, we should all know that the distance all the way around the circle is 360 degrees. What's another word for the distance around a circle? Well, the distance around a circle is our circumference. It's our circumference. And our circumference is equal to 2 times pi times our radius. Okay? Or in other words, our circumference is the total arc length if we went a total 360 degrees around our circle. So using our formula where theta is equal to our arc length over our radius, and we know that a full revolution of a circle is 360 degrees, and we know that that length is equivalent to our circumference, which is 2 times pi times the radius, and then if we divide by the radius to convert to radians, then we can see that 360 degrees is equivalent to 2 pi radians. And then we can, of course, divide by 2. Oh, I see that I'm getting in the way a little bit. Let me scroll down. We can divide by 2 to see that 180 degrees is equivalent to pi radians. Okay. Now let's solve some practice problems now that we've seen these relationships. So convert the following from degrees to I am a terrible speller. Let's fix that real fast. Convert from degrees to radians. There we go. Then graph on the unit circle. Okay, so we want to convert 60 degrees to radians. So we just saw that 180 degrees is equivalent to pi radians. And so what would 60 degrees be equal to? 60 degrees would be equal to some unknown x. And here we can just cross multiply to solve. 60 times pi is 60 pi. And that's going to be equal to 180 times x. And then we can divide both sides by 180. So we are left with 60 divided by 180 is, of course, 1 over 3. So we have pi over 3 is equal to our unknown x. So 60 degrees converted to radians is going to be pi over 3. So how do we graph this on our unit circle? Well, this is simply telling us that if we have theta, and theta is some 60 degrees, well then this location is not only 60 degrees, but it is also pi over 3 radians. All right, how about this one? How do we convert from 210 degrees to radians? So again, these are just setting up a simple proportion. We know that pi is to 180, and so 210 is going to be to some unknown amount of radians. Then we can just cross multiply to solve. So 210 times pi is 210 pi, and this equals x times 180, or 180x. Next, we can divide both sides by 180 and simplify and solve. We can cut out the zeros from each of these. Now we just have 21 over 18. We know that 21 is 7 times 3, and we know that 18 is 6 times 3. Therefore, we can take a 3 out of both of them and be left with 7 and 6 respectively. Therefore, we know that 7 pi over 6 is equivalent to x. So 210 degrees can convert nicely to 7 pi over 6 radians. Now, if we want to graph this, let's think about where 210 degrees would be. Half a circle is 180 degrees, or pi radians. And then if we add an additional 30 degrees to our half circle, we will get to 210 degrees. So this point would be 210 degrees, or 7 pi over 6. Very nice. Okay, let's clean up some space. Clean up some space and finish out these last couple ones. Okay. Excellent. And let's change color as well. Let's go to this nice green color. Okay, this one we have negative 45 degrees. Where would negative 45 degrees? Okay, so again, we set up our ratio to solve. We know that 180 degrees is to pi, as negative 45 degrees is to some unknown value x. And we can just cross multiply to solve to again get negative 45 degrees times pi is going to be equal to 180 degrees times x. Next, we can divide both sides by 180 degrees. Now it is important, well, recognize that 45 times 4 is 180. So whenever we divide both sides by 180, we can cancel out a 45 and just be left with pi over 4. So this will be negative pi over 4 is equivalent to our unknown value x. Okay, so let's graph this. So negative 45 degrees would be right here. So typically, if you haven't already learned this in school, degree measures counterclockwise, just like counting your quadrants. So you start here, and then you go in the circle counterclockwise, like that. However, if you're given a negative degree, then you'll have the same starting location, but you will go in the positive direction. So we would go this way 45 degrees instead. So that's how we can quickly know it will be right here. And we know that this is negative pi over 4 radians. Okay, let's solve these this last one. We have negative 310 degrees. Again, just set up your proportion. It's over some unknown radians, and it equals 180 over pi. You can cross multiply to get 180x equals negative 310, or negative 310 pi rather. We can divide both sides by 180. And I believe I might have messed up a little bit whenever I wrote this question. I'm probably meant to write negative 315 degrees because 31 and 18 don't simplify any further. That's okay though. That's okay. We can see that this will be negative 31 over 18 pi. And that's as simple as this one is, or gets. And let's graph this as well. So where would negative 310 be? Well, that would be 50 degrees in this direction, so it's about right here. So this would be negative 31 pi over 18 radians right here in this first quadrant. Excellent, excellent. Let's continue forward. Here we have some more practice problems, but for these we're converting from radians to degrees instead of degrees to radians. But the process is nearly identical. So 2 pi over 3 to degrees. Well, so 2 pi over 3, and we want to convert this to degrees. And again, what do we know? Well, we know that pi is to 180 degrees, and we want this to convert to some degree measure x. So we can cross multiply and solve and get 180 times 2 pi over 3. Now there's some canceling that's going to happen. So 180 times 2 pi over 3 is equal to pi times x. So 180 is 3 times 60. So we can pull out a 3 and cancel it with the denominator. And then left in the numerator, we have 60 times 2, which is 120 pi. 120 pi is equal to pi times x. We divide by both sides and the pi's cancel, leaving us 120 degrees is equal to x. So 2 pi over 3 is equivalent to 120 degrees. Where does this go? Well, we know that this top going straight up and down is 90 degrees, and then we're going to go an additional 30 degrees will be in our second quadrant. So around this location is the 120 degree mark. Okay, what about 11 pi over 6? Let's convert this one. So we set up here. I'm going to just erase this, change the work around a little bit. So we have 11 pi over 6. Here, let's change back to the pink color. We have 11 pi over 6 is to what degree measure? And we know that pi is to 180 degrees. So here's our ratio. We're going to cross multiply. And when we cross multiply, what do we get? Well, we're going to get 11 pi times 180, all divided by 6. 11 pi times 180, all divided by 6. Let's notice that 180 is 6 times 30. So we can cancel these out and be left with 11 times 30 pi. And this equals our right-hand side of pi times x. And then the pi's cancel. And you're left with just 11 times 30, which is 330 equals x. So 11 pi over 6 converts to 330 degrees. Okay, where is 330 degrees? Well, it's going to be right here, just about. This is at 330 degrees. Excellent. Let's solve this next one. Here's another negative problem. We have negative 7 pi over 4, and we want to convert it to some degree measure. And let's use what we know. We know that pi radians is equivalent to 180 degrees. We can cross multiply to get negative 7 times 180 times pi all over 4 is going to be equal to pi times x. So notice that 180 is 45 times 4. So this cancels out to be 45, and the 4 cancels. Now we can divide both sides by pi, and then we are simply left with x equals negative 7 times 45. And next, negative 7 times 45 is negative 315. And negative 315, we're going to be going clockwise 315 degrees and end up roughly here. So this location is negative 315 degrees, or in other words, negative 7 pi over 2. Okay, let's do this last one. This last one is negative 3 pi over 2. So how do we convert this? We set up our ratio, as we should be familiar with now. A lot of these problems are pretty similar. Here, let me clear up some space. Oops, deleted that axis. Let's put that back. There we go. So for this last one, negative 3 pi over 2 is to some unknown value in degrees. We know that pi is to 180 degrees, so we can just cross multiply to solve. So notice that we have negative 3. I hope y'all were able to see my work on the last one. I hope my picture didn't get in the way. We have negative 3 times 180 180 degrees times pi all over 2. And this is, of course, equal to pi times x. Again, we can simplify. 180 and 2 cancel out to leave you with 90. And the pi's cancel on both sides. And then you're left with negative 270 degrees is equal to x. So negative 270 degrees, that is going to be straight up here. And so this is negative 270. Excellent, excellent, excellent. Great work, everybody. There's converting from radians and degrees both ways. Now, lastly, real quick, let's try to label this full unit circle doing all the most basic ones. So the most basic ones in my mind are here, the 45 degree locations. We of course have 30, 60, 90. Okay, let's label all of these points. These are what I recommend having memorized whenever you're doing your own solving. So let's see if we can label all of these points. So labeling in degrees is easy, and we've already done a lot of work, so this is going to be super fast. So right here is at 0 degrees. This is 30 degrees. Here is 45. Here is 60. Up top is 90. Then we have 120. Oops, 120, there we go. And then we have 135. And next we have 150. A semicircle is 180 degrees. After 180, we have 210. Then we have 225. Then next we have 240. All the way down south, we have 270 degrees. Next, we have 300. Then we have 315. And last but certainly not least, we have 330. And then we circle back. The 0 degrees is, of course, also 360 degrees, etc., etc. So there is our full unit circle in degrees. Now let's think about our full unit circle in terms of radians. Okay, well, let's just focus on, let's start with 45. So again, our conversion, 45 degrees to radians. What are we going to do? Well, we know that 180 degrees is pi radians. And so you can just cross multiply to solve to get 180 degrees times x equals 45 times pi. And then we can divide both sides by 180 to get pi over 4. So 45 degrees can also be written as, here I'll change to purple, it can also be written as pi over 4. And if 45 degrees is pi over 4, then an additional 45 degrees, taking us up to 90, is going to be what? It's going to be 2 pi over 4. It's going to be 2 pi over 4, which of course simplifies to pi over 2. And then an additional 45 degrees will go from 2 pi over 4 to 3 pi over 4. And then 180 degrees will be 4 pi over 4, which is of course simplified down to pi. Then we have 225. That's going to be 5 pi over 4. Then we have 270. This is 6 pi over 4, which simplifies to 3 pi over 2. Then we have 315, which is 7 pi over 4. And we have 360 degrees, which is, of course, 0 radians or 2 pi. Excellent. Now let's focus in. Let's hone in on our 30 degree mark. Our 30 degree, I believe we already solved it up there. But if we erase this, change this to 30 degrees, we cross multiply, we're going to divide 180 into 30, and instead of pi over 4, we'll get pi over 6. So 30 degrees is pi over 6. That means an additional 30 degrees to taking you to 60 will be 2 pi over 6, or in other words, simplified, pi over 3. And then we have 90 degrees, which is pi over 2. So pi over 6, 2 pi over 6, 3 pi over 6. 120 is going to be 4 pi over 6, or 2 pi over 3. Then we have 5 pi over 6. 6 pi over 6 is 180. 7 pi over 6 is 210. 8 pi over 6 will be 240, and that simplifies to 4 pi over 3. Then we have 9 pi over 6. Then we have 10 pi over 6, which is, of course, 5 pi over 3. And then we have 11 pi over 6. 11 pi over 6. And then we have 12 pi over 6, which is our full circle, our full 2 pi. So there you have it. We just labeled our full unit circle in radians and degrees. That's how you do it. I hope you see that there's a pattern to it after a bit. You just keep adding pi over 6 whenever you're doing the 30s, or you keep adding pi over 4 whenever you're doing the multiples of 45. So there it is. There's converting radians to degrees. Let me know down below if you found this video helpful, and I'll see you in the next one.